All right, so we get to go over the actual midterm now. So this is always fun. So first question, is this function continuous? Justify. So we could see for places that were not continuous, we need to make one of those three continuity rules break. So the first rule is f of x has to exist. So we know that in this function and in all functions, the function doesn't exist if there's negatives inside the square root, or if we make the denominator 0. So in this case, there's no square roots. We don't need to do any square roots. So no negatives inside the square roots we don't really need to deal with. But the denominator is not allowed to be 0. And we do have a denominator, so we have to make x plus 2 not equal to 0. So here we can subtract 2 from both sides and get x is not allowed to be negative 2. So the function value does not exist when x equals negative true. That is a true statement. So yes is going to be gone. We have to pick no. Jump discontinuity would go with piecewise functions, so it's not that. Since we know that the value doesn't exist, it can't be d. We can go through and actually prove that it can't be d by finding the limit. To do the limit here, the limit as x approaches, here we would try negative 2, because that's what we want to find the limit of. X squared minus 4 over x plus 2. We have actually a couple options at this point. Since we did L'Hopital, if you want, you could L'Hopital this one. This person had wanted it to be one from unit 1, where we did factor cancel with the continuity rules. And so we would get x minus 2. So when we plug in negative 2 minus 2, we get the limit to be negative 4. So the limit actually does exist. The limit would be negative 4. So we can get rid of d also affirmatively. So that's that one. Number 2, find the limit of e to the x minus 1 over 2x. So as x approaches 0. So if we try to plug 0 in, e to the 0 minus 1 over 2 times 0, we'll get 0 over 0. That is indeterminate form. This person did want this one to be a L'Hopital question, so we're going to L'Hopital this one. So if we L'Hopital it, the derivative of the top, so we're going to do the limit as x approaches 0 of the derivative of the top. So that would be d dx of ex minus 1 over the derivative of the bottom is going to be derivative of e to the x is e to the x, derivative of 1 is 0, derivative of 2x is 2. And now if we plug 0 in, e to the 0 over 2, e to the 0, because anything to the 0 power except 0 is 1. So we get 1/2, and so that's going to be our value. We're going to get A for number 2. For number 3, we got an award already. So this award, if we check out all the stats, this question differentiated people the best, which is just good because it's a differentiation question. That means if you got this right, you probably did pretty good on the test. And if you missed it, you might have been one of the lower scorers on the test. But again, everybody did pretty decently on the test, so no shame in missing 1 or 2 of them. In this case, we got to find inverse tangent of x to the 4th. So we know that tangent, d dx of tangent of u, inverse tangent of u, is going to be u prime over 1 plus u squared. So again, that was one that we had to memorize. In this case, we want u to be x to the 4th, which means that du, or u prime, is going to be 4x to the 3rd. So we want 4x to the 3rd on top and 1 plus x to the 4th squared on the bottom, and that gives us choice E. It's the only one with the 4x to the 3rd up top. Again, you might have to be able to simplify to get one of the other ones, but it matched up pretty well. So we got E for that one. So if this was yours, congratulations. First place for the most differentiating question. Very nice. Number 4, everyone got this one right, so that's really good. So if you made this question, I'm sure everyone is very happy you made this question. What's the derivative of e to the x? The answer is e to the x. So that's one that we just have to memorize. So there we go for number 4. For 5, we want the derivative of 1 over 3x. None of these answers are correct, so somebody kind of tricked themselves. But if we want to do this one, it is a pretty cool power rule because we have to do 1/3 times x to the minus 1. So we can bring the negative 1 down and go x to the negative 2 and get negative 1 over 3x squared, which would be the correct answer. Some people said that they did a quotient rule trying to get this one. But yeah, none of these are right. So everybody just got the free point on that one. Maybe this is everybody's favorite question because no matter what answer you pick, you get it right. But this is what the answer would have been. For number 6, we have the whole tables. We have to find which one reflects A function for g where the limit as x approaches 10 of g of x is equal to 6. We got a lot of tables, but we want to make sure that we're going to 10. So in this case, we're only going to 6. In this case, we're going to 6. Here we're going to 10. Oops, let's grab that. Here we're going to 10, and here we're going to 10. So we can get rid of a and b right away. So that's kind of nice. Then for the second part, we have to make sure that our function value is approaching 6. The limit has to be 6. So if we look here, our limit is approaching 6. If we look here, we're approaching 6 on this side, but we're approaching 10 on that side. That's not a match. The limit doesn't exist. Here we're blowing up to infinity, and here it looks like I don't even know where we're going, maybe 4.5. Either way, it's not 6. So the answer to this one is going to be C. So for C is the correct table for this one. For 7, everyone got this one right too. I thought someone was going to get tricked by this one, but no one got tricked by this one. Derivative of a constant is always 0. So that's our derivative of a constant rule. dx of c is always going to be 0. So since 7 is just a number, the derivative is 0. For 8, we've got the firework. I think this one was on the review guide. I think I doubled this one up. Here we're trying to find the average acceleration. So that's going to be the y2 minus y1 over x2 minus x1 formula is our average rate of change. So in this case, we're going to do from 40 to 0 means we're going to go from 36 minus 4. And we have to go from 0 to 40. So we'll go 40 minus 0. So 32 over 40, which is 4/5. If we reduce it, this is the only choice that has 4/5. We have feet per second. When we do the derivative, we go one more. So feet per second would turn into feet per second squared. So our second squared is correct. So that was number 8. For number 9, find the derivative of cotangent of x. So we know derivative of tangent is secant squared. So derivative of cotangent is cosecant squared. But it begins with c, so we have to remember it's going to be a negative. So it's going to be a. For 10, we have to find this derivative. Here we've got the x's and the y's, so this one's an implicit question. So derivative of the left side is going to be 3. Derivative of the right side by the power rule will be 8y, dy dx, plus 6 dy dx. And we can follow our solving steps. So now what we need to do is move everything to one side, which is already done. So then we GCF out our dy dx. So we have 8y plus 6, and then we're going to divide both sides by the 8y plus 6. So those are going to cancel, so we get 3 over 8y plus 6 is equal to dy dx, which is going to be answer choice D. So we're going to get D for that one. All right, so for number 11, we have to find the limit as x approaches 0 for this graph. So as we approach 0, up at the top, we can see that we're headed towards 3. Down here at the bottom, we can see we're headed towards -3. So since those are not the same, this is going to be dne because we don't really know if we're at the top or if we're at the bottom. For 12, let x and y be functions of time such that the sum of x and twice y is constant. Which of the following describes the relation between the rate of change of x with respect to time? So this is kind of tricky. We have to go with respect to time. And the rate of change of y with respect to time. So we have to do the derivative with respect to time. So dx dt, if we take the derivative of x, it would be 1 dx dt. If we do this derivative, we would get 2 dy dt. And the derivative of the constant is always going to be 0. So we actually end up with 0 right here. So it looks like we're not going to pick this one because this is 2x dx dt. It definitely exists. We got dx dt plus 2, but we didn't get k as a function of t. That's not true. It's 0. So it's going to be one of these two. So I think they want us to subtract the 2 dy dt from both sides. And so we get dx dt is equal to -2 dy dt. Almost looks like my -2 is on top of a fraction there. And that's going to be choice A. So we're going to pick A for that one. For 13, what kind of discontinuity, if any, is at x equals -4? So if we look here at x equals -4, we can see we have this big gap. When we have that big gap, that's a jump discontinuity. A removable discontinuity is the same as a whole, so you shouldn't pick that one, but this would be the removable discontinuity. There's one right there. An infinite discontinuity, they don't have one on this graph, but that would be if there were some asymptotes. So if we were to throw an asymptote in like right here, that would be an infinite one. And the function is not continuous because we can see that there's a couple gaps in it. So that's what we got for 13. For 14, everyone got this one right too. I don't know, I thought this one was going to trick people also, but no one got tricked. 2 ways to do it. I'm going to do it the faster way, which is to multiply first and then do the derivative. I think some people did the product rule, but I mean, if you multiply first, you get 6x squared, and then the derivative of that is 12x. 12 times 3 is going to be 36. So that's what we get. This is f prime of x. This is f of x. And then this is f prime at 3. So that's what we got for that one. So nice job with that one, but that's 14. For 15, find the equation at line tangent to y equals 5x cubed minus 22x plus 1 at x equals 1. So since we need to find the line tangent, we're going to do y minus y1 equals mx minus x1. And we're told that x is going to be 1. So we know that x is 1, but that's really x1. If I were to plug 1 into this equation, we're really finding y1. So 5 times 1 cubed minus 22 times 1 plus 1. So 5 minus 22 plus 1 is going to be -16. So we got y minus -16. We don't know m yet, so I'll just leave that as m for right now. So next we got to get m and x. Well, we don't have to get x because we're finding the whole equation. So we need to get m. So to get m, we're going to find the derivative. So y prime is equal to 15x squared minus 22. So y prime at x equals 1 is going to be, when we plug 1 in, 15 times 1 squared minus 21, which is -6. Sorry, that's 22. -7. Like, there's no -6s over there. All right, -7. And that's going to be our slope. So here I've got plus 16, so I can minus 16 both sides. So y is equal to -7, x minus 1, minus 16. That's going to be answer choice B, and so that's what we got. For 16, we got another award. I think this is the Browns award here, but our graph is shown between 0 and 8, which is the following is true about the limit as x approaches 4. That's right here. Can't use black. Of f of x. So it turns out we want to find out which is true about the limit. So I know that the overall limit doesn't exist because here we're at 0, and here we're headed towards 4. And I know that 0 does not equal 4. So let's see. The limit equals 0. Well, that's not true because only one of them is. The limit as x approaches 4 is 2. Good fake answer, but not true. We don't average the limits. Limit is 4. That's not true. That's the right-handed limit, not the overall limit. The limit d and e, so that's true. Left and right-hand limits exist. That's true, but are not equal. That's true too. So I think I want to pick that one. Here, the limits do not exist. This limit's 0 and that limit's 4. So the limits do exist. So we don't want to pick E. We want to pick D for this one. So again, this one was a very nice question. 17, we got a silver trophy. So this is the second best one in terms of discriminating people into knowing what they're doing and not. So in this case, we got to find out which of the following is true for y equals g of x. I think I remember this one was a homework one that we went over, something very similar to this. So that's kind of cool. This person kind of moved the numbers around a little bit, so kind of nifty. But in this case, we need to get to the second derivative to check out a and b. We need the fourth derivative to check out g, d, or c, d, and e. So let's first find the first derivative. Oops, we don't have y this time. We got g prime. So derivative of sine of negative x is negative cosine of x, cosine of negative x. So the negative sign comes from the chain rule. That's why we got a negative there. Derivative of cosine of x is just negative sine of x. And then the derivative of negative 10 is 0, so I don't need to do anything for that one. Then I got to do g double prime of x. So derivative of negative x or negative cosine of negative x. Derivative of negative cosine is just regular sine, but negative thanks to our chain rule. Wait, no, derivative, yeah, because we got a negative and another negative, so we got to get to, oops, nope, that was right. And then we have the derivative of sine is cosine of x. So g double prime minus 10 is equal to g of x. That's not true because we see we've got no negative. Here we've got the negative, so that's out. G double prime is equal to sine of negative x plus cosine of x. That's not true because that's not what we got. So we'll move on. We have to get the third derivative. All right, so derivative of negative sine is negative cosine. But since we have the chain rule, we have to turn our negative into a positive. Derivative of negative cosine is positive sine. All right, fourth derivative then. Derivative of cosine is negative sine, but the derivative of the negative x for the chain rule makes that positive. Derivative of sine is going to be cosine. So we got the fourth derivative. So it says the fourth derivative is equal to the second one squared. That's not true because I don't have any squareds over here. So that's out. G4 of x is equal to g of x. Fourth derivative is not the same. Here we have this minus 10, so that's out. If I add 10 to the original, I would get the fourth derivative. And yeah, if I take away this negative 10, then I have sine of negative x plus cosine of x. So I'm going to pick E. All right, for 18, people moving into the city from the suburbs at a rate of C of P. People from the city are moving into the suburbs at a rate of S of P with P as people. Which inequality shows the rate of change of people moving into the city is positive? So if we're moving into the city, we are C of P. So we know that C of P needs to be greater than, because we need to be positive, S of P, because those are the people that are leaving the city. So if the people coming in are bigger than the people that are leaving, then our net change is positive. So we're going to go pick D. Now again, it says very specifically positive, not non-negative, so we don't pick E because 0 wouldn't count. We don't want 0. 19, use the table, estimate R prime of 1925. So we got to find where 1925 would go. It would fit in between these two. Since we're doing an estimation, that's an average rate of change. So we're going to do y2 minus y1 over x2 minus x1. So we've got 600 minus 450 over 1930 minus 1920. And they picked good numbers for a non-calculator question. It's pretty quick, 150 over 10, which is just going to be 15. All the units are raccoons per year, which is correct. But they didn't try and trick you with like a raccoons per year squared or something. So it is 15 raccoons per year. For 20, find the derivative of inverse sine of x squared. So again, this is another one of those inverse trig derivatives. So the derivative of sine of u, so d du of sine of u, is 1 over u prime over square root of 1 minus u, don't need parentheses there, u squared. All right, so we just say, all right, well, we know what u is. U is x squared, so that means that u prime is 2x. So we're going to get 2x over square root of 1 minus 2x squared. Not 2x squared, x squared squared. I hit my 2 in the wrong spots. There we go. So x squared squared is going to be x to the fourth. Again, this is the only one with an x to the fourth, so that's the one that we're going to pick. All right, 21. By utilizing the intermediate value theorem, which the following domains contains a solution to the polynomial equation f of x is equal to 2x cubed minus 5x squared minus 20. So remember, a solution is when x is equal to 0. So we have to find out what the zeros of the function are of this, which normally, I mean, in algebra class, we'd probably have to graph that. We would, because it doesn't look like it factors or anything nice like that. So we would probably have to graph it to find about where the solution was. So this is kind of cool that we can do it with calculus. Looking at my answer choices, the one that I'm trying first is D, because D looks very suspicious that those are the same number. So that would mean that it's only at 4. So that would mean that if I were to plug in 4, I should get 0 if D is the correct choice. So 2 times 4 to the third minus 5 times 4 squared minus 20. 4 to the third is 64, so 2 times 64 minus 5 times 4 squared, that's 5 times 16 minus 20. So this is 2 times 64. We're going to split that up into 64 plus 64. 5 times 16 is minus a 64 minus a 16 minus 20. Plus 64 minus 64 cancel. 16 and 20 is 36. That's the best way. 44, 34, 28. Hey, we get some positive number. That's all that matters. It's not 0. So this one's out. We get some positive value. So f of 4 is positive. Positive. All right, so that means that that's out. So now I have to pick something else. Now, logically, I should choose either C or E because I already know what 4 is. And the intermediate values theorem is going to state that if 28 is positive, hopefully one of these is going to give me a negative number, because to go from positive to negative, I would have to pass through 0. Because, again, we want to find out where it's x equals 0. If I'm trying it, again, I'm going to try 5 first. I think it's easier to plug 5 into an equation than 3. So I'm going to try f of 5. 2 times 5 to the third minus 5 times 5 squared minus 20. So this is 2 times 125 minus 5 to the third is 125 minus 20. So that's going to give us 105 pretty quick. This is also positive. So going from positive to positive, I don't need to pass through 0, so that's out. All right, now I'm just kind of hoping it's C, because if it's not C, I got to work back to B. So f of 3. So this is going to be 2 times 3 cubed minus 5 times 3 squared minus 20. So this is 27, 2 times 27 minus, this is going to be 5 times 9 is 45 minus 20. 54 minus 45 minus 20. So that's going to be 9. So negative 11, which is negative. Okay, perfect. So from 3 to 4, I go from negative to positive. Since I go from negative to positive, or if I were to go from positive to negative, I must pass through 0. So that's how I know it's got to be C. So that's how we go for that one. Very cool. I actually really like this one. This was one that kind of made you think a little bit about calculus, connected to some of the stuff that you did before in algebra. So this was a really cool question. I like this one. 22, surprisingly, you see a note that has now been passed back to you from under the closet door. It reads, find the derivative of sine of x times 7x squared, and you'll find answers. What's the answer? Well, that's a multiplication. Multiplication means we're doing the power rule. So power rule is first times the derivative of the second. So 2 times 7 times x plus the second, 7x squared, times the derivative of the first times cosine of x. This is 14x sine of x plus 7x squared cosine of x. 14x sine of x. 14x sine of x. Oh, there's a 14x sine of x. There's a 14x sine of x. Nope, nope, nope. And then plus 7x squared cosine of x. This one's got the plus, so we're going to pick E. Oops. I want to say this is product rule. All right, 23. H of x is less than or equal to f of x, which is less than or equal to g of x. Limit of h of x as x approaches 8 is 4. Limit of g of x as x approaches 8 is 4. Which of the following must be true? Well, since f is in between them, this is a squeeze theorem. And by the squeeze theorem, that means that the limits have to be the same. The limit of h of x has to be the same as the limit of g of x, which has to be the same as the limit of f of x. So that's a really terrible limit notation. I can't leave it like that. The limit as x approaches 8 of h of x is equal to the limit as x approaches 8 of g of x is equal to the limit as x approaches 8 of f of x, and all of those have to be equal to 4. So the value is not what we're going for. The limit of f of x as x approaches 8 is 4. Yeah, I would say this. The limit of f of x when x is 8. So we have to be careful. We can't pick is 8 because we're approaching 8. We're not actually becoming 8. As x approaches infinity, that's out because it's with the squeeze theorem. We're only going to the certain value that both of them approach, which is 8. So we don't pick that one. So let's see. 24, we find the derivative for x to the 6th power. This is a power rule 1. So 6x, 6 minus 1 is 5. So 6x to the 5th. So there we go. 25, everyone got this one right, which is kind of cool because the chain rule is kind of tough. So it says use the chain rule. With the chain rule, we could also do the general power rule. 5, 3x plus 2 to the 4th times the derivative of the inside. Derivative of the inside is 3. So that's going to be 15, 3x plus 2 to the 4th. That's going to be e. So there we go. So pretty nice. Everyone did really good on that, whether you did the general power rule or the full chain rule. This is our other gold one. So it turns out that 2 of them actually had the same amount in terms of quality for determining which question was good at determining who did super well and who did not do it super well. So with this one, we have to evaluate the limit as x approaches 3. I think this person wanted it to become x minus 3 squared over x minus 3. Obviously, if you want, you can L'Hopital it. If you plug in 3, you'll get 0 over 0. But this way, we get x minus 3 because the squared and the x minus 3 cancel. And then 3 minus 3 is 0. So interesting. It's not DNE. 0 is a valid answer. You are allowed to get 0. This one does end up being 0. 27, Michael has an issue, too much winning. He thinks his skill in chess is directly related to the amount of games he plays. According to him, how is the rate that his skill is rising measured? So this is important because it says his skill is rising. And a lot of people, when they miss this one, they pick the one that was just the skill in the game. So in this case, it's directly related. So skill is going to be equal to some constant k times the amount of games that he plays. So that means that if we do a skill per games or a games per skill, we're just going to get a constant. We're not actually going to get how the skill is rising. That's just going to be the value at one game because we don't know how many games that he's playing at that point. So in this case, our rating is going to be going up per day because it has to be the amount of games that he's playing. And he can't just play one game. This would only be if he played one game. A lot of people pick this one. But that's why it can't be D, because D is just one game, and it's not a rising. That would just be at one specific point. We want a rising, so we need to continue continuity of different games. So that's what we got for that one. So that one ends up being C. Pretty tricky, very technical with the English, but I mean, contact the person that wrote that. 28, this graph is shown. What's the instantaneous rate of change of fx at x equals 2.137? Since it's a straight line, the instantaneous rate of change is equal to the slope. So we can just find the slope. We're going to rise 1, run 2. And since it's a line, that's true for every single point on that line. So 1/2 is the correct answer. This one gets the gold ostrich award because it had an ostrich in it. If it has an ostrich in it, it has to make the test. So an ostrich moving through the desert is represented on the x-axis by the position of the ostrich and time with the y, which best estimates the speed of the ostrich at t equals 6. We can see at 6 we have a straight line. The slope is 0. So our slope is going to be the derivative of position. So x prime of t is velocity. And in this case, since the slope is 0, the velocity has to be 0. Not v of t. This is now v of 6. Excellent. Nice job with that question. I like that one a lot. Always good to have an ostrich question on the test. Everybody's least favorite, apparently. There were complaints about the cone, but somebody wrote a cone question, so cone question made it. This is a dreads question, so we got the cone. It's being filled at a rate, so dv dt is 8 inches per minute, inches cubed per minute. The ice cream cone has a height of 10 and a diameter of 4. We know that the radius is really what we're after. Find the rate of change when the cone is filled to a height of 5 inches, which means that the radius would have to be 1 inch because it's a fifth of that. I think that's everything we need. I think the rate box is all set. Yeah, because we're trying to find the rate of change of the radius. We need dr dt. All right, so our equation for this, pretty solid. V of a cone is 1/3 pi r squared h. We know that the height is 5 times as big as the radius, so 1/3 pi r squared times 5r. We'll simplify things to make the derivative a little bit easier to find. So 5/3 pi r cubed. When we do our derivative, the 3 is just going to cancel out the 3 that's over there. So dv dt is equal to 5 pi r squared dr dt by the power rule. We want to get dr dt by itself, so we'll divide both sides by 5 pi r squared. So dv dt over 5, this is the solve step at this point, pi r squared is dr dt, and we'll substitute in. Let's see what we got. So we got 8 over 5 pi, r is 1, so 1 squared is dr dt. So 8 over 5 pi, there's only one 8 over 5 pi. So we pick A. So that's it with the cone. That was the cone question. Here we have to say which of the following explains why f is not continuous at x equals 1. So it's already telling us that it's not continuous. So this is another one where we have to use those continuity rules to figure out what the answer is. So first we're going to check to see if f of 1 exists. So let's check to see if this exists by saying, well, there's no square roots in even roots, so we're okay there. But x minus 1 is not allowed to be 0. And if I add 1 to both sides, x is not allowed to be 1. So f of 1 does not exist. So neither one exists would still be okay. The limit exists, but f of 1 does not exist would still be okay. F of 1 exists is out. Both exist is out. Both exist is out. Now I need to check the limit because I have to decide between A or B. So the limit as x approaches 1 of 1 over x minus 1. If I were to plug it in, and you don't need to do L'Hopital if you don't want to, but this one looks like a good choice for L'Hopital because we get 0 over 0, which is indeterminate form, which is a L'Hopital. What we get to do then is take the derivatives. So the limit as x approaches 1 of the derivative of 1 minus x over the derivative of x minus 1, which is going to be negative 1, not negative x, negative 1 over 1, which if I plug 1 in, there's nothing to plug it into. It's just always negative 1. So the limit does exist. It turns out for this one, the limit is going to be negative 1. So the limit does exist, so we pick B. All right, 32, what's the instantaneous rate of change? Whenever x does not equal 1, so it's saying, all right, find the derivative, because we want the instantaneous rate of change. This is our code word for derivative. So we're dividing, so this is going to be a quotient rule. So pretty straightforward interpretation. It looks like it's set up pretty nice that we can just kind of do it and then be done. So low d high, so that's going to be 3x squared minus high x cubed plus 2 d low, that's just 1, square the bottom, x minus 1 squared, and away we go. Now it looks like this person also didn't want us to simplify, so that's even better. So we just have to pick with whatever we've got. X minus 1, 3x squared minus x squared, x cubed plus 2 times 1 over, yep, that's it. So everything matches up in D, so I'm just going to pick D. All right, and then last one, everyone got the last one right, so always good to end on one that everyone gets right. Which of the following best describes the phrase, the limit of a function of x as x approaches 10 is 2. So the limit of a function of x as x approaches 10 is 2. Was negative 2. All right, so that's going to be choice D. So again, everyone got that right. No one got tricked with E. I thought some people were going to get tricked with E, but nobody got tricked with E, which is nice. So that's it. That's all of them. So pretty nice. The other thing that I get to say then at the end of this one is the secret is they're all in alphabetical order by your initials. So if you want to know who to blame, now you have a new puzzle to solve over the break. Good luck. Have a good break, and we'll see everybody in January.